In this video, I'll show how to analyze a circuit that has multiple power supplies. You can see that in this circuit there are two different batteries, one with 1.5 volts, one at 9 volts. Here I've redrawn the circuit. I've listed them as resistance A, resistance B, voltage C, and voltage D, then given the values here. What we're looking for in this question is the current through A and the current through B, so these two. The first thing I like to do is try and put pluses and minuses on each component. So for a battery, the long side is the plus, short side is the minus. For the resistors and other components, I do my best to figure out which side is more positive than the other. For this resistor, I can see that both batteries have their pluses here and their minuses there, so I think current's going to go through it this way, from this plus side to the minus side. This one's more complicated. So one power supply's got the plus pushing this way and the other one's got the plus pushing that way. I don't know which way to do it, so I'm just going to take a guess. So I'm going to put plus up here and minus down there. Now, using Kirchoffs loop rule, what I want to do is find the simplest loop I can find. And that, I think, would be this one. So if I start here and go around this loop clockwise, what I find, the loop rule says delta V in a loop is 0 volts. So in this case, that means 0 volts has to be, if I start here, I go through plus VC, and then around here from plus to minus, I'm going down, so minus the voltage through part A. So if I rearrange this, 0 is what, that means VC equals VA. This resistor has VC across it, and VC is 1.5 volts. 1.5 volts across that resistor. Now I can pick another loop. Any loop works. The obvious one that you might think I would do next is this one, because it looks so similar to that one. And you can do that. There's no problem with doing that. I'm going to do a different one just to show you that it can be done in multiple ways. I'm going to start actually in this corner. And since I looped clockwise last time, let's loop counterclockwise this time. Again, it doesn't matter which way you go. Either direction will work. So delta V for that loop, again, has to be 0 volts. And starting here, I go from the minus to the plus through RB. So that means I'm going plus VB. Nothing here, nothing here, nothing here. I go from plus to minus on the VC. So I'm going down through VC, minus VC. And here I'm going from minus to plus, so I'm going up through VD. I know what VC and VD are. I'm solving for VB. So rearranging this gives VB equals VC minus VD. VC, that is 1.5 volts minus 9.0 volts. So VB is negative 7.5 volts. I chose plus here and minus there, and then I ended up with a negative number. That means my initial guess about which side is more positive than the other was wrong. So in fact, this is the positive side of the resistor, and that's the negative. And there's 7.5 volts across it. Alright, so now I've found this one, negative 7.5 volts from that plus to that minus. Now all I have to do to find I for each of them, I use Ohm's law, V equals IR. Then I can rearrange this to say that for A, so resistor A, IA equals VA over RA, which is 1.5 volts over 10 ohms, which is 0.15 amps. For IB is VB over RB, which is, so this was 7.5 volts over, RB is 20 ohms. I took the negative sign out. The reason I did that is because if you're just asking for the current, that's the magnitude of the current that you want. If it's asked for the direction of the current, then you look at this minus and say, well, current flows from plus to minus, except that there's negative 7.5 volts, so I know the current's flowing upward through this one. So the current's actually flowing upward here and downward there. But the magnitude of the current, 0.375 amps.